the Eurasian Plate. This is one of a series on the major plates of the Earth. The Eurasian Plate's about the third largest behind the Pacific and North American plates. And to proceed, we have here the red boundary to the Eurasian Plate. It's a bit confusing in this configuration, but the Central Atlantic at about 10 o'clock extends into the North Atlantic through Iceland to the east of Greenland. It then extends through the Arctic Ocean, where the word North American Plate or American Plate is written. It slides through Siberia and swings southward towards Japan and into China in 2 excursions, although a lot of people would include the areas out as far essentially as Japan within the main Eurasian Plate. Similarly, the Sunda Plate, marked down there at 4 o'clock, is often regarded as the major mass of the Eurasian Plate, but there's a distinct separation when we come to talk about the secondary plates. The boundary north of the Indian Plate, the Himalayas, of course, are running through Burma to the Himalayas, is a zone of crushing, as in fact much of the southern border, with the exception of the region through the Sea of Arabia and the Red Sea, which is shown here as excluded. The Arabian Plate has separated essentially from the African Plate and is crushing against the Eurasian Plate in the Zagros Mountains of Iran and Iraq, just north of the word Arabian Plate. And there's discussion also whether or not the Eurasian Plate should include the small plates of Anatolia in Turkey with the arrow in it, or the Hellenic Plate of the south of Greece, but it extends through roughly through Sicily and just clips the northern margin of the continent of Africa before exiting in the Gibraltar Straits and crossing to the mid-ridge of the Atlantic Ocean up at 10 o'clock in the middle of those arrows. That, of course, is a separating zone again, but the major area of the Mediterranean is a zone of crushing. Now, to read that article there, the west side of the Eurasian Plate shares a divergent plate boundary with the North American Plate and moves away from it at the rate of about 3 centimetres per year. It shares Iceland with the North American Plate, and that's spreading at something of the order of 3 centimetres per year with the North American Plate. And the south side is largely compressed against the African, Arabian, Indo-Australian and Pacific plates. There are exceptions to that, of course, in that the Arabian Plate is moving independently, and so are a number of smaller plates, even the Sunda Plate, as mentioned before. Looking again at that plate configuration, the red zones across the north, that's from the North Atlantic through the Arctic Ocean, are zones of expansion, with the green zones just sliding contact or transfer margin. The same applies really in China, where that separate plate, the Amurian Plate, has been separated, and the Yangtze Plate also. They're effectively expanding sections of the Eurasian Plate, which are tending to break away. The Sunda Plate, likewise, in the bottom right-hand corner. But as we come across through Burma, there's a certain amount of compression associated with the transfer fault shown in green. But you have complete compression continent to continent in the Indian Plate against Eurasian Plate in the Himalayas and Tibetan Plateau. Again, through Baluchistan, Iran, and Iraq along the contact with the Arabian Plate, shown in bright blue again. Transverse faults mark the contacts through, well, Afghanistan, beg your pardon, Iraq through to Turkey, where the number 23 is shown just off centre to the left. And you have these complex small plates being disturbed in the Eastern Mediterranean. This shows the boundary running just north of Sicily and then out through the southern Mediterranean, actually clipping the continental margin of North Africa, Tunisia and Morocco. And the very tip of Morocco is included there with the Eurasian Plate. And then mainly transverse faults out to the central Atlantic at 10 or 11 o'clock. The wording underneath, the only oceanic crust of the Eurasian Plate extends westward to the mid-Atlantic ridge in the North Atlantic and to the Gackel Ridge in the Arctic. Notable exclusions from the plate are the Amur Plate of Manchuria and the Yangtze and Sunda Plates in Southeast Asia. Many discussions would include those. This is that northern margin. If we can orient ourselves, the white block is Greenland, of course. To the east of that, we can see the North Atlantic ridge running through Iceland and taking bends to twist it around Svalbard and including the North Pole in the North American plate, with the Eurasian Plate having large areas of essentially ice-free ocean north of Russia, Siberia, and then the red margin of the two plates, the Eurasian North American Plate, runs through at 11 o'clock, runs through Siberia, and it's shown here extending down towards Japan, although modern usage cuts it from this position straight through the Kamchatka Peninsula, which is protruding there at an 11 o'clock angle, and joins the Aleutian Trench at the North American Plate. Looking again at a more traditional artist's version from the National Geographic, the blue boundary at 3 o'clock is the compressional boundary through the Western Mediterranean. It joins what we said a moment ago, is a lot of transverse structures there, which are transform faults, not plate boundaries, not referred to necessarily as transfers. And then the central ridge of the Northern Atlantic runs northward with a displacement about halfway up the transfer fault or a plate margin, and or transform, often referred to. It then extends, the central ridge then extends the red line through the centre of Iceland at the very top margin of the diagram. If we're looking at the eastward projection from the central Atlantic, these blue arrows are a bit interesting in that it's not shown as a separation in the central Atlantic in that point, but suffice to say the Eurasian Plate has a general southeasterly movement, and it is certainly separating in the North Atlantic. The African Plate has an essential rotation anti-clockwise against the Eurasian Plate, and you can just see where it's impinging on the Tunisian-Moroccan borders there, Libya, etc. And the complexity in the Aegean Sea, the little expanding plate actually being subducted by the oceanic crust of the African Plate, applies also really with the Anatolian Plate in Crete, that you have oceanic areas of the African Plate sliding in under the Eurasian Plate. Of course, this was very notable in recent past, in the last 50 million years or so, with the construction of alpine Carpathian ranges running through the Pontips or Taurian ranges of Turkey and into the Zagros to the east of the Arabian Plate, where there's been much northward thrusting of Africa and Arabia against the Eurasian Plate. There's another presentation of that work. It shows pretty much what's just been discussed, the main compressional zone running through the Mediterranean and then continuing around north of the Arabian Plate into eastern Turkey and Iran, or Iraq, I beg your pardon. There's also the green belt running south through the Dead Sea Rift, which is the separation of Arabia and African plates. The word here is the compressional plate boundary through the Mediterranean meets with the margin of the Arabian Minor Plate in Iraq, and it extends through the Zagros Mountains of Iran, which are not shown in this diagram. We can see the great arcs of the Alpine ranges north of Italy and the Carpathians swinging moving back a little bit here, there's a complexity westward, and there appears to be a new subduction zone occurring off Portugal, which may well in the future extend and start to subduct material, which is an interesting thing for the future of the North Atlantic. But we can see here clearly defined the boundaries between the Eurasian Plate and African Plate, or in the top 10, 11 o'clock position, it's of course North American Plate. A huge tsunami occurred in Lisbon, which destroyed much of the city and certainly the Admiralty, which had very, very valuable maps in those years, even of Australia, it is believed, well before Cook's work in 1760. But another tsunami followed an earthquake in 1969, which was dramatic in Lisbon and felt through much of France. And this zone where it occurred is regarded as being the origin of a new subduction zone. And it's been stated that it could eventually swallow the North Atlantic because it's an eastward dipping subduction zone, which would start to draw the Pacific, the North Atlantic Ocean floor in under Europe. If it were to extend to the north, and it's regarded as a possible origin of a new long subduction zone, which would extend along the continental margin of Europe. It's speculation. Extending our ideas of this southern margin from the edge of the North American Plate eastward through the compressional zone. We've dealt with the Mediterranean and mentioned the Zagros running north of Arabia and the areas of Bukhara, Balochistan between there and India, the Himalayas of India, and the compressional zones in Burma and Thailand, etc. The margin of the plate, as I said, commonly sort of thought of as running almost east to include Japan and Kamchatka right up at 2 o'clock position. you can see the subduction zones at the edge of the Pacific Plate. And of course, the two major plates, Pacific and Eurasian plates, are pressing against one another in this region, and the subduction of the oceanic Pacific Plate is causing the Pacific Rim of Fire, and many discussions will regard that as a contact between the Pacific and Eurasian plates. However, there are a number of small platelets which are outlined in this diagram, starting in the south adjacent to the India Plate with the Sunda Plate, and then the Yangtze, followed by the Amurian Plate and the Okhotsk Plate north of Japan, or including Japan. Well, the latter was for a long time included with the North American Plate, which is actually the far top right-hand corner of this diagram is North American Plate, bounded by a transverse fault in green, and then the plate makes a triangular shape, including the Yucatan Peninsula down to include Hokkaido and half the main island of Japan. It's a very unstable region of Earth, as we know, because of the complexity of the Kuril Japanese subduction zone. I comment here, the southern margin of the Eurasian Plate is largely under compression. Purple boundaries are regions under compression, notably the Mediterranean, Zagros and Makran regions, that's Balochistan, Western Pakistan, and the Himalayas, also Myanmar, Burma and East Asia. The remainder of the border is largely under expansion through China and Siberia. Looking just more detail, the red hatching applies to areas that are a weaker crust. They're relatively recent ocean materials that have been possibly thinner crust being crushed by the immense tectonic forces of movement of African Plate and Indian Plate against Eurasia, so that we have mountain building and earthquake zones extending throughout those hatched areas. And of course, this includes the Great Rift Valley of East Africa. Also in the bottom right-hand corner, there's a hatched zone, which is the possible future plate boundary, or the one that's accepted essentially as separating the India Plate from the Australian Plate today. We see the Alps and the areas of Greece and Italy, Tunisia, etc., are also unstable, as is Turkey, south of the Black Sea and Caspian Sea areas through Iran and Iraq, are all subject to very significant earthquakes today as a result of the collision, essentially, between Eurasian Plate and the African Plate. This shows clearly Dead Sea Fault, the Red Sea structure, and a hotspot, a circle of red based on the Afar Triangle, which is where three plate boundaries meet, the expansional zones of the Red Sea, Sea of Arabia, and the East African Rift. There are other smaller hotspots marked under that African Plate. And so generally this diagram shows the regions of tectonic activity along the southern margin of the Eurasian Plate. These are all effectively active mountain building by faulting, often thrust faulting, and prominent earthquakes occur throughout the region on transverse faults as well. Looking in more detail at the Eurasian Plate through some of this region, the blue zone with triangles, of course, are subduction belts, and there's a prominent one circulating between Greece and Crete, and that's defining a plate that's expanding currently as new oceanic material associated with the Aegean Plate. it's being subducted by the African plate, as is all this eastern portion of the Mediterranean. Just a few zones of straight compression without subduction. And then it's picked up by extensional and transverse faulting of significance running across the top of the Anatolian plate in Turkey. Very large earthquakes, of course, occur along that far east side, south of the Black Sea. VAM had a significant earthquake 15 or so years ago, and many more occur as one gets into the Siamamia, or south of the Black Sea and Istanbul, which is where the two small spots occur, red spots occur on the top of the Anatolian plate. Suffice to say, through the Zagros Mountains of in the east, through Iraq and Iran, it's shown as compression of continent to continent. That's the purple coloration, with some green transverse faulting, or transfer faulting, as it's referred to for a plate boundary. The areas of grey, the top left-hand section of the diagram and the right-hand higher section, these are areas of intense deformation of the rocks. So there's orogeny effectively going on, or mountain building, in the form of large thrust and transverse faults due to this conflict of major plates, the Eurasian, African and Arabian plate. Just my comments on the bottom, there's a rift along the boundary between the Aegean and Anatolian plates, red, which developed due to the retreating Hellenic subduction zone, making the Aegean Sea relatively young. It's moving southwards, or expanding southwards at 37 millimetres a year. That's 37 kilometres in a million years. So it's quite significant, and accounts for the region of Santorini, where there are a series of volcanics, huge caldera eruption of Santorini at about the beginning of that arrow 37 within the Aegean plate. The Eastern Med is subducting below this blue trend, Eastern Mediterranean portion of the African plate. Moving a little further east, this just defines more clearly the connection of the Arabian plate and its influence on Eurasia, particularly in this case, Afghanistan, Iran, and also, of course, Anatolian plate, which is being twisted rather like an orange seed or something or other by the northward movement of the Arabian plate. The resistance offered by the Eurasian plate results in the Anatolian plate being twisted anti-clockwise. Indian plate moving northward at 26 millimetres a year is effectively crushing into the Himalayas and causing them to rise about a centimetre every year. And these plate boundaries, again, purple is just compression. There's only subduction marked here is in the Mediterranean Ocean, where you've got ocean-to-ocean contact. Otherwise, it's largely continent to continent, and the green sliding fault structures or transfers for plate boundaries, whereas the red zones are expanding, creating new oceanic crust and enlarging the Arabian and African plates. The states of the Arabian plates only relatively recently separated from Africa, less than 50 million years ago, and is colliding with the Eurasian plate in the Zagros Mountains of Iran and Iraq. Moving eastward again to the India and Sunda plate regions, also at 2 or 3 o'clock with a motion southwards of 15 millimeters a year is the Yangtze Plate in China. But most of China is part of this Persia-Tibet-Burma Orogeny, meaning mountain building instability due to perhaps weaker crust and the northward thrust of the Indian Plate. Continent-to-continent collision for the last 20 million years or more has resulted in the high Himalayan mountains and the very elevated Tibetan Plateau. It's still shown as moving northwards at nearly 30 millimeters a year, which of course is largely resulting in uplift of the thin crustal regions of the Tibetan Plateau and Himalayas. Translation shown with intense structural activity or tectonic activity in Myanmar, Burma, with a complex margin to a little small Burma plate, which is the edge of the Sunda Plate, being having Indian Ocean and Australian Plate subducting beneath it. In fact, this new boundary of the India-Australian Plate, marked in black dashed line, would account for the epicenter of the Aceh tsunami in 2004, where that plate margin effectively is being subducted beneath the northern tip of Sumatra. The Sunda Plate will be discussed separately. It's undergoing complex compression and sliding, and also new separation for this Burma Plate, which is being created essentially south of the structure through the Irrawaddy of Burma. Commenting only now on the Yangtze Plate, one can see that there's a separation of this new plate out at 2 o'clock, which is traditionally regarded as part of the main Eurasian bloc. Just to explain that continent plate collision in the Himalayas, that results in mountain building due to the fact that subduction, which initially was going on until 20 or so million years ago, with the Indian Plate effectively sliding under the Eurasian Plate because of the oceanic crust. When the main mass of the Indian continent started to collide, and certainly from 20 million years ago, we've had crushing and mountain building that accounts for the very high Himalaya and Tibetan Plateau on the Eurasian Plate. There's much overthrusting of the material of the Eurasian Plate, not shown here, and there's intrusion of volcanic rocks within the Himalayas and certainly the southern portion of the Tibetan Plateau. That's where that subducting plate has reached, about 100 kilometres, and what with the fluids carried down from ancient oceanic crust and sediments, this lowers temperature of melting, so you've got a magma generation zone about 100 kilometres down where the plates are actually undergoing their sliding, and due to gravity the magmas rise and are present as eruptions in the region of Tibet. And this reads orogeny or orogenesis is the process of mountain building due to the collision of tectonic plates, and one should really say continent to continent plate collision. There are very broad areas of Southeast Asia that are influenced by that current collision. One of those is the Sunda block, which not very clearly defined here, except for a very prominent subduction belt from the Indian Plate, running from the top left of the diagram, sweeping around, known as the Sunda Java Trench or various other names. You see Sumatran Trench at times. It's the subduction of the oceanic portion of the Indian and Australian plates beneath the Sunda block, or beneath Indonesia in general. Then there's that highly complex zone in the northeast quadrant where the Pacific plate, here represented by a fractured version of the Philippine plate, essentially the same westward thrust, under-thrusting the Philippines in that northeast quadrant, and effectively causing double directional subduction, so that oceanic material of the South China Sea is also sliding under the Philippines. Gives it an extraordinarily unstable situation tectonically. We get very significant earthquakes in the Philippines and tsunamis, as we're aware. We can see a peculiar relationship in the bottom right region of the diagram or picture, where there's a horseshoe type bend, and the Turkey's head of West Irian points through zones of subduction with this bend called the Banda arc, resulting in very complex geology in the region of Sulawesi and the Spice Isles and the Turkey's head of PNG. This will be dealt with separately on another occasion. So that Sunda land block, or Sunda block, is a complex zone of interaction of three major plates, effectively Indo-Australian, Pacific, and the Eurasian plates. Here's another version of that same region, a little more extensive. It shows the Yangtze Plate in the north with its southward movement of 15 millimetres a year, Philippine Sea Plate, and we've cut off its boundary with the Pacific Plate, but essentially both are moving westward at 80 to 90 millimetres a year. And the small plate extends south from Japan towards Taiwan in the north there, with a little 54 and 71 just above the P of Philippine. That plate is only a fraction or a fractured portion of the east section of the Philippine Sea Plate. Sunda Plate marked strongly by subduction of oceanic crust from the east moving westward, and from the southwest moving northward, related to the Indo-Australian plate. So it's under considerable compression, also compression from the fact that India's been forcing itself against the continental mass of Eurasia in the north, and there's an attempt, you might say, of stress escape from that region. So there are pressures through the projection of the eastern, of the Eurasian plate there, pressures tending to be to the southeast, as shown in the Yangtze Plate, for example, at 15 millimetre per annum. Just reading the bottom, the Sunda Plate is a mosaic of fragments derived from Gondwana, and that's a surprise we'll learn in later discussions, that Borneo, portions of Borneo, certainly Sumatra, Burma, and even sections of the Singapore Peninsula, etc., have been derived from Gondwana, or from the Australia-India, Greater India boundaries in the history of going back several 100 million years. One memorable eruption of this region has been Krakatau of 1883. It was felt or heard in Melbourne, Adelaide, and it caused the collapse of a large stratovolcano, and resulted today in a large flooded caldera with a new Anak Krakatau growing from it. And just a small cinder cone, or small significant volcano, but nothing like the original Krakatau, which entirely disappeared in the eruption of 1883. Tsunamis at that time devastated coastlines of Java and Sumatra, and ash dropped over 50 kilometres away. And it was 44 years before Krakatau surfaced and started to build a new volcanic cone. This occurred at the subduction zone between Sunda and the Australian Plate, and is the Java Trench Zone, where subduction of oceanic crust of the Australian Plate has reached a depth of about 100 kilometres, and therefore produces magma, which erupted very explosively as a result of water included within the magmas. Looking at the major influence of the Pacific Plate on the Eurasian Plate, of course, this is the Pacific Rim of Fire, the subduction zones all the way around the western section and even through North America of the enlarging Pacific Plate, sliding in beneath the Eurasian and North American plates. Even as shown in the bottom left, under the Australian Plate between Samoa and Papua New Guinea. So very significant subduction has carried on there for probably over 150 million years. The oldest oceanic crust in the world is known along that eastern margin of the Philippine Plate as part of the largely oceanic Pacific Plate, and it gets to be 160, 180 million years old, and that is effectively the oldest known oceanic crust. Of course, you have the great recycling system of oceanic crust presently being developed along the Pacific Rise in the east there, down at 4 o'clock in the very corner of the diagram. We have expansion between the Cocos, Nazca and Pacific Plates going on, which is driving a 95 millimetre per year movement of the plate northwestward, which is illustrated by the extinct line of volcanoes of the Hawaiian Ridge. There's a Hawaiian hotspot shown by a triangle as this line of extinct volcanoes. As the plate has moved across, it's carried the volcanic edifice away from its hotspot, so they become extinct. And Midway Island and the far end of that Hawaiian Ridge is something the order of 42 million years, I think, and it has been extinct that long, having been moved off by plate movement that period ago. Certainly lines extend away from Caroline and Samoa, Marquesas and Society Islands, but the most pronounced is the Hawaiian Island Ridge, which changes direction some 40 million years ago, a bit prior to that, 45 million years or something like that, into the Emperor seamounts, suggests or indicating that the Pacific Plate originally moved more northward than currently. That line of extinct volcanoes extends right up to the Aleutian Trench near the Kamchatka Peninsula. We notice the Kuriil Trench running down to Japan and the Philippine Plate impinging on the what is classified here as the general Eurasian Plate, without showing the Yangtze and Amurian plates. So we say the Pacific and Philippine plates are subducting under the extensions of the Eurasian Plate, the Western Pacific region, resulting in its fragmentation into the Sunda, Yangtze and Amur plates and the Okinawa mini plate, which is extending south from Japan along the Philippine Plate margin. This diagram is just popped in there to show the Eurasian Plate in China, And the definition of the Eurasian Plate, which is largely expanding, as shown in red there, it's a spreading zone. So there's likely to be volcanic activity along it. Ultimately may form distinct rift valleys and even separate as a new ocean, but is regarded as a smaller plate boundary today, for that Yangtze Plate, separating it from the main Eurasian Plate. In the same way, the Sunda Sea Plate cuts through Southeast Asia in the far bottom left, expanding to form Rift Valley, you might say, ultimately through southern Burma or Singapore Peninsula of Malaysia. And just the plate boundary as defined as a weakly extended zone coming south of the Philippines as a subduction zone under the Pacific Plate, surprisingly, showing that there's eastward movement of the Sunda Sea Plate from the pressures of Eurasia. And Taiwan is a complex zone which meets subduction from the edge of the Philippine Plate, but extension to the west of that, of the Yangtze Plate, separating probably as a result of some phenomenon of that subduction zone on the eastern side, so clearly marked by the change in colour of blue, running up to the east of the southern islands of Japan. Looking again at those plate boundaries, we identified Thailand, etc., on the Sunda Plate, and the Philippines on the contact between the Philippine Sea Plate and the Sunda Plate. Subduction essentially from westward movement of the oceanic crust of the Philippine Plate. And this continues to form the Okinawa Plate with subduction under the Kuril Japan subduction zone. And we notice that there's a certain separation going on there as the Okinawa Plate shown as moving 54 millimetres per year southeastward, where the Philippine Plate is moving in the opposite direction at 71 millimetres. So where all meet in northern Taiwan, it's an extraordinarily risky tectonic situation of meeting plate boundaries. A small mini plate, the Okinawa, the Yangtze Plate trying to move southeast, and the Sunda Plate, if it shows any pressures at all, is moving eastward. So it's quite complex. We get up to the north and the southern islands of Japan, with Korea showing just where A of Amur and B of Plate appears. It's the southern end of the peninsula of Korea and South Korea. The expansion within the China Sea to the west of that, and tensional zone with that Amur Plate moving southward 10 millimetres per year. Altogether, the western section of this diagram is shaded grey to indicate that there's instability, or can we say mountain building or orogeny, going on in a general way across much of that Eurasian Plate, a result of crust or material involved in the subduction of oceanic stuff from the east. The Amur Plate of North China, Manchuria. Again, many people would include this within the Eurasian Plate. I won't discuss it in great detail. It seems to be separating off or sliding off in the northern section from the Eurasian Plate. But the Japanese island chain is very much involved with subduction from the Pacific Plate. We have discussed the Yangtze Plate to the south. And we start to get influence from the North American Plate, or the Okhotsk Plate, where we, in the top right-hand corner, we see 13 millimetres per year southwesterly directed movement, and that's effectively influenced by the contact with the North American plate through Siberia. And just to read this now, the process of tectonic subduction has pulled a piece of the Earth's surface layer, or lithosphere, more than 500 kilometres beneath northeastern China. And this region is about 1,000 kilometres from the Japan Trench, where the Pacific Plate begins its plunge back into the planet's interior. So by study of earthquake waves and effectively applying the principles of tomography, or picturing things that are hidden within a body, as we do in the human body with tomography, it can be done in Earth's mantle by virtue of the deflection of earthquake waves by masses of different density. And so they appreciate that 1,000 kilometres away from the Japan Trench, you can see fragments of crustal material that appear to have resulted from the action of subduction. And here's a picture actually a bit further south than that last picture, because this is running through effectively through the Manila Trench, the Philippines. It would have been better to follow an earlier slide there. In the South China Sea, it's south of Taiwan, as one can read there more or less centrally. And you're looking at what they call the Nankai Trough there rather than the Japan Kuril Trough. And there's also a Ryukyu U Trench. I didn't know that name previously. Suffice to say that there's a great deal of study being done. This perhaps is confusing from the different plates identified. The most simple is out on the right-hand side, in this three-dimensional diagram, looking at the Mariana Trench, the Pacific Plate. This is the deepest oceanic trench on Earth, where the Pacific Plate is actually sliding under the Philippine Sea Plate. And there's a very clearly defined Pacific slab extending 1,000 kilometres or so deep down into the Earth's mantle. And they are identifying China Sea and East Asian Sea slabs at depth beneath the Philippines, for example, or beneath the Manila Trench. And there's a portion of the Eurasian slab identified in white there centrally, again, where the main mass of Eurasia, disregarding the fractured section of the Yangtze or Sunda plates, has seemed to be subducted previously through the Manila Trench or under the Philippines and located at significant depth within the mantle. This is reading this again, a tomographic transect across the East Asian mantle under the Eurasian South China Sea margin, the Philippine Sea and the Western Pacific. Well, we're moving north. Just to read this first, in the Far East, the Eurasian and North American plates meet in Siberia, and that's circled. It's an unexpected result unless one studied the North American plate, which incidentally was previously extended down to include much of Japan. And we're unaware from earthquake activity of a significant plate boundary where this green transverse marked fault is marked westward, westward from the Kamchatka Peninsula, or the top of the peninsula, across into Siberia. That's now regarded as the North American plate boundary. There's not a significant difference in plate movement as measured. The North American plate, 18 degrees, essentially a little south of west, and the Okhotsk plate, about 13 millimetres a year. The two plates are more or less obeying the movement of the great mass of North America. The section of ocean east of the Kamchatka Peninsula is North American Plate, and it's being subducted by the Pacific Plate in the bottom right, even though that's moving northwestward at 92 millimetres a year in the Kuril Trench under the Okhotsk Plate. So there's quite a twist on the directions of movement there. You can see where the main mass of the Eurasian Plate is regarded as being separated gradually from the Okhotsk. There's a millimetre per year difference in their movement, and yet that's regarded as separation. The Okhotsk Plate moving only 1 millimetre year slower than the Eurasian Plate itself. Then to the south, there's the Amurian Plate, slightly slower movement, almost due south, 10 millimetres a year. So there's compression between that and the Okhotsk Plate, shown in purple. And that includes a significant amount of Japan, the northern island and part of the main island, or half the main island, almost to Tokyo. And it's no wonder Tokyo cops some earthquakes when you look at the junction of the Philippine Plate, the Okhotsk Plate, the Kuril, sorry, not so much the Kuril Trench, Japan Trench, which is just offshore, and of course the volcanism of Mount Fuji and its related volcanoes in central Japan are due to that subduction zone, combination of that and the Philippine Trench to the west. And the Amurian Plate joins with the Yangtze Plate, very southern tip of Japan. Did I read this? In the Far East, the Eurasian and North American plates meet in Siberia, which is circled. And previously, North American Plate was extended down to include much of Japan. The Pacific Plate is subducting westward in the Kuril Trench underneath the Okhotsk Sea. Just reading this, a magnitude 9 earthquake struck in the Pacific Ocean off the northeast coast of Japan's Honshu Island on March the 11th, 2011, called the Great East Japan Earthquake. It triggered a massive tsunami that flooded more than 200 square miles of coastal land. We say that waves were estimated to be as high as 38 metres, height of a 12-storey building. Estimated 20,000 people were lost and close to 500,000 people were forced to evacuate. In addition, a nuclear power plant meltdown triggered an emergency, and the direct economic loss from all these phenomena is estimated somewhere around 360 billion American dollars. Though Japan is a world leader in disaster preparedness, this earthquake caused overwhelming damage and humanitarian needs. Required, of course, international response. These two red stars indicate recent major earthquakes. I guess the northern one was the main concern for the earthquake just discussed, and more recently there's been one closer in to the main cities of Japan, or to Tokyo in particular, which had a small tsunami, but nothing compared with that from 2011. We look here at the Amur Plate, which covers much of China and Manchuria, and extends into the Baikal Rift, which is an elongate, often largely winter frozen lake on the Trans-Siberian Railway. Lake Baikal often gets featured, and it's an extensional phenomenon related to this relatively newly recognised Amur Plate, and it's considered that it may well separate ultimately from the main mass of Eurasia, and hence warrants the significance as a plate in its own right. These two coloured spots in the north are calculations of the rotation, the relative rotation between the North American and Eurasian plates. Of course, if you've got two plates on a globe twisting or grating against one another, the only way you can define their movement is by a central pole. And these are poles of relative rotation of Eurasia and the North American plate. And they're regarded as different. The blue circle is calculated from GPS movements of the ground relative to stars, you might say. And it differs geologically from that determined by the geology, which is the green circle. After all, there's been some relative reorganisation of plate movement within the last few million years, and the geology tends to show an average over 50 million or so years, hence the difference between what is actually happening today and what happened in the last 20 million years. This diagram shows fairly clearly where that boundary is going off into the Arctic Ocean. That's the boundary between the North American plate, NAM, and the Eurasian plate, EURA. It's going as a spreading plate or oceanic construction or plate into the Arctic Ocean. The North Pole lies on the North American plate, and ultimately the boundary between the two comes down westerly of Svalbard, easterly of Greenland, and through Iceland into the North Atlantic. The Okhotsk plate includes half that Kamchatka Peninsula, that's OKH, and the North Island, or half North Island Hokkaido. You'll notice there is a difference here in the plate boundaries, where in our previous diagram, that western boundary or the Okhotsk plate extended right down to Tokyo, so that we do get different interpretations in different papers. So generally, we've covered the entire plate without any detail across the Arctic Ocean in the north, but that red boundary extends from the last point of discussion, top edge of the Amur Plate in the top right-hand corner, right across Siberia, right through the Arctic Ocean, through the northernmost stretches of the Denmark Sea or the likes to Iceland, just under the word North American, which covers Greenland, and right around through the northern to central Atlantic Ocean, mostly extensional boundary, whereas extending through, or the transverse faults carry it to Gibraltar, and then you have largely compressional margin to the Eurasian plate running essentially right through to India and Burma, even some of the Sunda plate. So the southern section is largely compressional as a result of the African, Arabian, Indian, Australian plates pushing northward, whereas surprisingly, where the subduction zones of the Pacific are most notable in the region of Japan, section of the plate is actually, Eurasian plate is actually breaking off the Amur and Yangtze plates, and finally get to the Okhotsk plate, which likewise is part of this separation phenomenon that goes all the way across the northern section of the Eurasian plate. So to finish off, large stresses can be present on the edge of the plates. There are often no rigid boundaries, and there is often an area in which displacements are incompatible with the movement of the whole plate. What is notable on this diagram too is the shaded area marked as the Alps orogeny or the Persia-Tibet-Burma orogeny. This is still currently a mountain building zone that extends from Central Europe through Eastern Europe, Asia, and East Asia, as a result of the closure of enormous ocean areas of 200 million years ago, or even 100 million years ago, right through to really essentially the present day, where the remnants of those oceans are the Caspian and Black Seas and portion of the Mediterranean. But that area shaded was once the amazing Tethys Ocean complex, which will be discussed in much later geology. At this point, we're closed to questions. I have one question there to elaborate a little on the Spain-Gibraltar region. Well, this is a bit complex. Perhaps if I pick a slide here and show a very different boundary here between African Plate and Eurasian Plate, just to show how different workers would apply different principles to defining the plates. In this case, they're suggesting plate movements don't give the directions very obviously here, but they do show Eurasian Plate as moving northeastward, which is something of a surprise. Eastward might have been my angle, but the Iberian Plate moving in the same, and the African Plate all moving pretty much around the 25 to 30 millimetres a year. Now, the African Plate in general in the past has rotated a little bit anti-clockwise relative to the Eurasian Plate. And this has resulted in the Alps, that crush zone or mountain thrust zone marked by the parallel lines, and subduction marked along its northern boundary. Well, strictly speaking, those are not subduction zones, although illustrated in the manner that we would normally see them in blue-coloured lines with triangular margin directing thrusts. I think in this case, it simply implies that there are southward moving thrusts in the north, northward moving thrusts in the south, and that this is a reasonable position to put a major boundary between the Eurasian Plate and African Plate. Certainly in geological times, this would be, in the last 50 million years, this would be quite a reasonable boundary. Whereas today, we take it as an extension of the white line, which is shown west of the Iberian Plate, and the concept that there's subduction just starting of Atlantic oceanic crust under the Iberian Plate, as marked there. And it's considered to be the very beginning of a subduction zone that may move north along the European continental margins. Suffice to say, a lot goes on in the region of major plate boundaries. They're difficult to define sharply, usually done by frequency of earthquakes, of course, what is moving today. And these may differ from a geological diagram presented as this would be perhaps 20 million years ago. And I've written here, the Iberian Plate on the western edge of the Eurasian Plate is essentially part of the African Plate, or has been, whereas now there's a very complex subduction zone running through that towards the Isles of Corsica and Sardinia. It not only encompasses the Iberian Peninsula, but also the islands and areas surrounding Corsica and Sardinia. But as I mentioned earlier, there's also a peculiar horseshoe-shaped subduction zone extending westward through the Straits of Gibraltar. So we'll need to discuss this in more detail at a later time. And this is just an indication that complex mini plates lie on the margins of bigger plates, and that you get zones of significant deformation, which make it difficult at any time to define exactly what is and what was in past time plate boundary.